Section 11.5. We are getting close to the end of this chapter. We've got one more section after this one. Section 11.5 covers properties of inscribed angles. So let's talk about what that means. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So if we're drawing that in our picture here, it really can look almost like anything. Basically, you're going to put 3 points on your circle. So you can even decide where those 3 points are going to go. And you're going to turn connect two of those into chords. And there we would have an inscribed angle. Okay, the vertex is on the circle. The sides of the angle are chords of the circle. The arc lies in the interior of an inscribed angle. So that means it's the arc that connects the two endpoints that did not make a chord. So I'll highlight that in a different color. This is the arc that we're then talking about. It has endpoints on the angle, and it is called the intercepted arc of the circle. So if we were to name these X, Y, Z, name those points, the inscribed angle in my picture is angle X, Y, Z. And the intercepted arc is going to be arc X, Z. So we've got an inscribed angle that forms an intercepted arc. If an angle is inscribed in a circle, then its measure is half the intercepted arc. So I would also write down this shorthand version of that, either next to the picture or under the rule.
So is the words the rule?
Yes, the words up at the top is our rule. If an angle is inscribed in a circle, then its measure is half the intercepted arc. So you'll notice in the picture that they gave us, they said that inscribed angle measured 110 degrees because that is half as much as the arc that it intercepts, the 220. So the angle is half the arc. All right, you've already got these diagrams, so that makes this go quicker. We are asked to find the value of x. So remember, the angle is half of the arc. So if the angle is 50, the arc had to be... No. The angle is half the arc. So angle equals 1/2 arc. So x had to have been 100 if half of that was 50. The other way we could write this would be to say that the arc is equal to 2 times the angle. So if you would rather write it that way, that's another way of writing it. The arc is 2 times the angle, or the angle is half of the arc. On number 2, are we looking for an angle or an arc? We're looking for an arc, a very large arc. So the arc is equal to 2 times the inscribed angle. So 2 times 115 is 230. Sure, they should have put the degree symbol on the X initially, but yes, these are measured in degrees. All right, number 3 gets a little bit tricky because they did not give us this arc here that's intercepted by our inscribed angle. They did give us the central angle for that arc. What do we know about central angles and arcs? They are congruent. So, if the central angle here is 120, then the arc is 120. And now we're looking for an inscribed angle. An angle is half the arc, so that x equals 60. So that would be our answer. X is equal to 60. At the very bottom of the front side, we're talking about inscribed and circumscribed polygons. If all the vertices of a polygon lie on the circle, the polygon is inscribed in the circle. And we could say the circle is circumscribed about the polygon. The polygon is an inscribed polygon, and the circle is a circumscribed circle. Now we've got pictures showing an inscribed triangle and an inscribed quadrilateral. We can have other inscribed polygons. These are just the ones we're focusing on. Yes. We need the pictures so we know what this looks like.
All these words go into one box.
Yes.
Like both points, like the other point will go in the other box.
No, we're going to get to the other box later. Right now we're just talking about triangles. Later on we'll talk about quadrilaterals. If a triangle is inscribed in a circle, is a right triangle, then the hypotenuse is a diameter of the circle. If a triangle inscribed a circle is a right triangle, then the hypotenuse is a diameter. You don't really have to put of the circle. We know we're talking about a circle. So if you're looking to shorten it a little bit, you could knock off the of the circle. It's a diameter. Of course, it's of a circle. If a side of a triangle inscribed a circle is a diameter, then the triangle is a right triangle. Again, if you're looking to shorten this up, instead of writing out the word triangle every time, what could you put? A little triangle. Instead of writing out the word circle every time, what could you put? A little circle. Yes, it might look like a 0. If you want to, instead of putting the words right triangle, draw a little right triangle, you could do that. So if we look at the diagram that they gave us, you'll notice that the triangle is inside of the circle. All the vertices, A, B, and C, are on the circle. It's a right triangle. So the hypotenuse, which is across from the right angle, that would be AC, is a diameter because it goes through the center of the circle. So these theorems are basically reverse of each other. If you know that it's a right triangle, the hypotenuse is a diameter. If a side of an inscribed triangle is the diameter, then you know it's a right triangle. Works both ways, just like yesterday's theorems. All right, on these examples, we are working to find both x and y. So we have a triangle inscribed in a circle where one side is the diameter. So that means this must be what kind of triangle? A right triangle. A right triangle has to have what kind of angle in it? A right angle, which measures... Whoop. So y is going to have a measure... Bring it back. Y is going to have a measure of 90. How are we going to figure out x, Julian? Why is x equal to 30?
Because it's a 30, 60, 90 triangle.
Okay, it's a 30, 60, 90 triangle would be one reason. Also, all three angles have to add up to 180. All right, on number 5, which angle is going to have to be our right angle? X, because the right angle has to be across from the diameter. So x is going to equal 90. Y will have to be 45. Again, we had to know that this is a diameter. It goes through the center. X is across from it. It's right angle. On number 6, which one has to be our right angle? Y. So y is 90. And what is x going to be? 58. If a quadrilateral can be inscribed in a circle, then its opposite angles are supplementary. If the opposite angles of a quadrilateral are supplementary, then the quadrilateral can be inscribed in a circle. Now, I believe that the first bullet point is more useful to us. It's not going to be terribly often that you're asked whether or not a quadrilateral can be inscribed in a circle, but it is a possibility. So you'll notice in the diagram they labeled two of the angles x and y. The angle across from the y is 180 minus y. So I'll write that a little bit bigger if we need to see that. 180 minus y. Because that would make these supplementary to each other, opposite angles. Same thing goes with the x and the angle across from it. It's labeled 180 minus x. In these examples, we're still finding the values of x and y. So on number 7, x is across from which angle? 92. So x and 92 have to be supplementary, meaning they add up to 180. So what will x equal? 88. Y is across from which angle? The 60. So y would have to equal 120 for those to be supplementary. Number 8. What's the value of x? 70. That would be supplementary to the 110. What about y? 95 would be supplementary to the one across the 85. Number 9. What's the value of x? 83 for x. That's across from the 97. What about y? 101 is supplementary to the 79 across from it.